Hello everybody, welcome into another lesson. So today we are going to talk about functions. So what are functions exactly? Well, functions are they're equations basically. They're equations of two or more variables where if you put in one number, which is the input, you get out one and only one number for the output. It's a special type of relation where each input has one and only one output. If it has more than one output, it's not a function. And if it has no output, it's also not a function. So what's unique about functions, each input has exactly one output, one and only one. So there are three ways to determine if something's a function or not. One way, which we're going to demonstrate with a couple, is numerically. So numerically, first, you might have a table of values here. So the input, like when the input is 7, you get an output of 13. That's the only output you get for 7. You see 7 nowhere else in your input list. When it's 8, you get an output of 16. When the input's 9, you get an output of 11. When the input's 10, you get an output of 15. When the input is 11, you get an output of 39. So, something to check for whenever you're dealing with tables of numbers or a chart of numbers, do any of these input values repeat? If so, it's not a function. If it doesn't repeat, like in this one, you have a function. So, this totally is a function. We actually do have an example of a function here because each input has exactly one and only one output. Okay, now let's change it up a little bit here. Let me just delete this here, erase that. Why am I saying delete? We're not on a computer. It'd be nice if I could just type some of this in. That would really save some time. Maybe I get a smart board someday. But I'm not going to hold my breath for that one. Alright. So, let's see. The input, we have an input of 1. You get an output of 2. You have an input of 2, you get an output of 5. Input of 3, you get an output of 6. Input of 1, you get an output of 3. Input of 4, you get an output of 7. Okay. So here with this particular example, you have an input of 1 and output of 2. You have an input of 2 gives you an output of 5. You have an input of 3 gives you an output of 6. Then we have 1 again. This time the input of 1 gives you an output of 3. And then an input of 4 gives you an output of 7. Well, we notice the 1s repeat on the input. They have two different values. So, since we have a repeat in this series, this is not a function. It's a relation because in order for it to be a relation, every input must have at least one output. But for it to be a function, every input must have one and only one output. Well, the input 1 has two outputs of 2 and 3, so therefore this system is not a function. So this is numerically how to tell if something's a function or not. Next, we're going to go to graphically. Now, actually, let's do algebraically first. Let's do algebraically first, okay? Say you're given y equals x plus 4. So now we're dealing with equations here. Alright? X is your input. X traditionally is your input. also called your domain. Your input is also your domain. So the input, your x, are the values you put into x, okay? The domain expands upon that in the fact of what values is x defined for? Are there any values for which x is not defined for? In this particular case, there's no values for which x isn't defined for. In other words, what value of x would make this equation undefined? Well, there aren't any. We don't have a denominator at all. We just have a simple equation of a line, so your domain would be all real numbers. That's good news. On the other hand, your y variable is your output. Y is your output. So you input x, whenever you input something into x, you get an output for y. You get a y value. Your output is also known as your range. So x is your input, the value you put in, also known as your domain. Y is therefore the output you get after you put a value in for x, which is your range, which would also be the possible range of values that you could get for y as a result of any values you put in for x. Well, in this case, it would also be all real numbers. That would also be a range. But, so algebraically, how do we tell? Well, if I stick in any value for x, no matter what the value is, I only have one result for y. It's only going to give me one result for y. So if I stick in one value of x, I only get one y. Or if I stick in one value in the input, I only have one and only one output. Or if I stick in something in the domain, I have one and only one member of the range. Okay. How about y equals x squared minus 2? So we have y equals x squared minus 2. So, once again, take any value you wish for x. Alright? If I stick in any value for x, I'm going to have one and only one value for y. So therefore, it's also y equals x squared minus 2 as a function. Now, what if I gave you something like this? We have y squared equals x squared plus 4. So we have y squared equals x squared plus 4. That almost looks like a function. I'm going to show you why it's not, though. I'll prove to you why it's not. Let's move this over here a little bit. In order to find y, which we want, we got to take the square root of both sides. Take the square root of y squared, you just get y. But you got to do it to the right-hand side, too, of x squared plus 4. But remember, your right-hand side, when you take a square root, you actually have plus or minus the square root of x squared plus 4. So y equals plus and minus the square root of x squared plus 4. So really you have two equations for y. That means any value of x I put in, any value at all, I'm actually going to get two answers for y. If you have a situation such as this is not a function, because you put in one value of x, but you're going to get out two values of y because you have both plus and minus the square root of x squared plus 4. Or let's say we have, once again, I'll do y squared equals 16 minus x squared. So we have y squared equals 16 minus x squared. Well, is this going to be a function or not? Well, what do we know? We have to solve for the y, so we got to take the square root of y. If you do that, you do in fact just get y, but you also got to take the square root of the right side, and you know for the right side it's plus and minus the square root of the right side. It'd be plus or minus the square root of 16 minus x squared. So y equals plus or minus the square root of 16 minus x squared. Now pick any value you like for x. It doesn't matter which one you're thinking of. Put that in. You're going to get two values for y because you have plus or minus the square root of the right hand side. So you would get two outputs for one input, or two y values for one x value. Therefore, this something like, basically if you see a y squared to begin with, it's not going to be a function. The y has to be, for now in Algebra 2 you'll see it can be other things, but for now here in Algebra 1 the y should be to the first power in order for it to be a function. And on the right hand side it should not be both plus and minus for it to be a function. That's basically a dead giveaway algebraically that this is not a function, because you'll have two solutions for y for each solution of x. Alright. Now, we will get to graphically. Let's deal with the graphically real quick. This won't take long at all. So I'm going to draw me a nice coordinate plane here, okay? So we've done numerically and we've done algebraically. Now we're going to do graphically. Alright, let's see. -1, -1, 0, 0, 1, 1. So I'm going to draw me a nice function here, which is the classic one of y equals x. This is the classic one here of y equals x. How do we tell if graphically if a function, if a line or an equation's a function? It's called the vertical line test. If you could take a vertical line and it only intersects the line at one point, or the figure itself at one point, if it intersects at one and only one point, it's a function. If it intersected at more than one point, it's not a function. So if it intersects at one and only one point, this is in fact a function. And you could draw as many vertical lines as you want through this, it'll keep coming up a function. So that's something to keep in mind here. All right, what about something like this? I'm just trying to draw sufficient points so I can draw a good graph here. If you're wondering what this is called a parabola, which you're going to learn more about here actually in Algebra 1. This is the graph of the classic y equals x squared. This is the graph of y equals x squared. You always get a parabola. So if I did the vertical line test on this particular one, doesn't matter where I draw it, I'm still getting a function because it intersects at one and only one point. So y equals x squared is a function. Alright. Let's see here. What if we do, let's see, 0, 0, let's see, 1, 1, negative 1, 1, 2, 2, negative 2, 2. What if I have a graph of something like this? What if I have a graph of something like that? If you're wondering what this one is, this is the graph of y equals the absolute value of x. That's what y equals the absolute value of x looks like. If I do the vertical line test on this one, well, still intersecting at only one point, so yes, this is in fact a function. So y equals the absolute value of x is actually still a function. Alright, what if I'm just going to draw a few more points here. What if this time I have x equals y squared? X equals y squared. Interesting thing happens. So x would be 0 still, because x is still your input. Now, if x is 1, y would be plus or minus 1. If x is 4, y would be plus or minus 2. So what you get, this is still considered a parabola. And we're going to learn about different types of parabolas. Definitely in Algebra 2 it gets more introduced when we do something called conic sections. We'll talk more about parabolas at that time. However, graphically, if we look at x equals y squared, let's do the vertical line test. Immediately after drawing one line, you see it passes through 2 points on the curve. Therefore, this is not a function. And if you want to know why x equals y squared is not a function algebraically, we can turn this around, use properties of equality to say y squared equals x, which would have to mean y equals plus or minus the square root of x. Therefore, we have 2 values of y for every 1 input of x, so that can't work. That won't be a function, so graphically that's a way to determine also. So if your vertical line test goes through more than 1 point on the curve, you do not have a function. You may have a relation, but you don't have a function. From this point forward, throughout your studies, for the rest of Algebra 1, all the way through Algebra 2, pre-calc, calculus and all that, we're dealing exclusively with functions. So, the good news is in the upcoming lessons, you're going to only be dealing with functions for the most part. So, you'll be able to assume everything's a function for the most part. But that's basically it for functions themselves. Let's get into talk about what the next lesson's going to be here. The very next lesson is going to be functions defined by equations. Excuse me. They will be functions defined by equations, and we will talk more about what some other terminology we can use besides y equals something. So I hope everybody has a good day. Take care.